Okay, welcome to today's tutorial. In this video, we're going to look at motion, right? So, what is motion? Motion is a continuous change in position of a body with time. It is a continuous change in position of a body with time, right? So, if an object is here and then moves to here, right? As the object is moving, it is undergoing what? Motion. That continuous change in position of a body with time is referred to as what? Motion. Motion is the continuous change in position of a body with time, right? Motions in physics are studied with motion graphs, right? And we have basically three types of motion graphs. We have displacement time graph, distance time graph, and the velocity time graph. And this is the one that is most commonly used in physics, the velocity time graph, right? So let's look at the distance time graph, which is the first one that we have. And it is a graph, it's a motion graph that shows how the distance of a moving body changes with time. It shows how the distance of a moving body changes with time. So there are two things that are considered here, the distance and what time. So this is an example of a distance time graph. Your vertical axis, which is your y-axis, represents your distance in meters, and your x-axis, which is the horizontal axis, represents your time in seconds, right? So if here you would see that if here is A and here is B, right? Here is C, here is D. As the body moves upward, right? As it moves upward from this point, from this position A to B to C to D, as it moves from A to B, it is undergoing what is called what? Uniform speed. So this slope here is your uniform what? Is your uniform speed for a distance time graph. Why is it uniform speed? Because the distance is changing with time, right? The distance is changing so with the time. So if here is 1, if here is 0, here is 1, here is 2, here is 3, here is 4, here is 5, when it gets to B, it has already attained a distance of what? 5 meters, right? If here is 1, here is 2, here is 3, here is 4, here is 5, here is 6, here is 7. By moving upward, it has already attained a time of what? 3 seconds. So you can see that the distance is changing with time, and that is why we have here to be what? Uniform speed. So from B to C is uniform distance. What does that mean? The distance remains the same, the distance is constant, but the time is what? Changing. C to D represents our uniform negative what? Speed. What that means is that the distance is decreasing and the time is what? Increasing. So that gives us our uniform negative what? Speed. Then we have the displacement time graph. It is a graph, it is a motion graph that shows how the displacement of a moving body changes with time, right? It shows how the displacement of a moving body changes with time. So the two things here, displacement and time. So the vertical axis, which is our y-axis, represents our displacement in meters, while the horizontal axis represents our time in seconds, right? So if here is A, here is B, here is C, and here is D. As the body moves from A to B, the displacement of the body is changing, so with the time. So if here is 1, here is 2, here is 3, 4, 5, 6. Here is 1, 2, 3, 4, 5, 6, 7. As the body moves upward from A to B, it attains a displacement of what? 6 meters, right? And so the body's displacement is changing with what? With time. So from A to B represents our uniform velocity, right? Velocity is displacement over time, right? Displacement is changing with what? Time, right? So that is our uniform velocity. So this slope represents our what? Uniform velocity. Why? Because the displacement of the body is changing with what? With time. Then BC, B to C represents our uniform displacement, right? Uniform displacement. It means that from B to C, there is no change in displacement. The displacement is the same, but the time is changing, right? So it is 6 here, it is also 6 meters here. That is why it is uniform displacement. Also, in our distance time graph, it is uniform distance. B to C is uniform distance, right? Because the distance is not changing. It is 5 at B, it is also 5 at C, right? So this is our uniform displacement, and CD, which is from here to here, is our uniform negative velocity, right? Uniform negative velocity. Why is it negative? Because the displacement is what reducing, right? So that represents our uniform negative velocity. So the last motion graph that we'll look at here is the velocity time graph. And like I said before, this is the most important in physics. So the velocity time graph is a motion graph that shows how the velocity of a moving body changes with time, right? So it shows how the velocity of a moving body changes with time. So this, on the vertical axis, y-axis is our velocity, which is measured in meters per second, right? So this is in meters per second. And on the horizontal axis is our x-axis, which represents the time measured in seconds, right? So here will be 1 meter per second, 2 meters per second, 3 meters per second, 4 meters per second, right? So this represents, this axis, this vertical axis represents our velocity, and this horizontal axis represents our time, right? So if here is A, here is B, here is C, and here is D, AB, which is from here to here, represents our uniform acceleration, right? Acceleration in the sense that velocity is changing with what? With time. So if here is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, 7 seconds, the AB represents our uniform acceleration. Why? Because the velocity is changing with what? With time. So you should know that this slope AB is our uniform what? Acceleration, which is what we have here. Then BC is our uniform velocity. What does that tell you? That the velocity is constant, right? Is the same, is not changing, but the time is changing, right? Then CD is our uniform negative acceleration. So CD is our uniform what? Negative acceleration, also referred to as what? Retardation. So this is also our retardation, right? So you should know what the different points in this graph, what they symbolize, right? Right through the distance time graph, the displacement time graph, down to the velocity time graph. So having known all this, let's look at this question that we have here. So the question that I have here is, a car starts from rest, accelerates at 1 meters per second square for 10 seconds. It then continues at a steady speed for a further 20 seconds and decelerates to rest in 5 seconds. Find A, the distance traveled in meters, B, the average speed in meters per second, and C, the time to cover half the distance, right? So the first thing I would want to do here is to draw out the graph for this motion, is to draw a motion graph, right? So a car starts from rest, it starts from rest. So I would have to draw my vertical axis, right? And I would like to draw my horizontal axis, right? So again, a car starts from rest. So this is the rest position. A car starts from rest, accelerates at 1 meters per second for 10 seconds. So the car starts from rest and accelerates, right? It accelerates at 1 meters per second for what? 10 seconds, right? So that tells you that from here to here is what? 10 seconds. So this is 10 seconds. So this is our time, right? And this would be our velocity. So this is my y-axis, which will represent my what? My velocity in meters per seconds. And this is my time, which is represented in what? Seconds, which is measured in seconds. So a car starts from rest, accelerates at 1 meters per second. So the acceleration was at what? 1 meters per second squared, right? For 10 seconds, for a time of 10 seconds. It then continues at a steady speed for a further 20 seconds. Steady speed simply means what? Uniform speed or uniform velocity, right? So it continues for a steady speed, right? For what? 20 seconds. So it continued at a steady speed for what? 20 seconds. So from here to here is what? 20 seconds. Or continue with that steady speed, which is uniform velocity, right? And decelerates to rest in 5 seconds. So it then decelerates. So this represents your deceleration. It decelerates to rest in 5 seconds. So from here to here is what? 5 seconds, right? 5 seconds. So this is 20 seconds. This is 10 seconds, 5 seconds, right? It decelerates. It decelerates to rest in what? 5 seconds. So the first question that I have here is to find the distance measured in meters. So the distance here, the distance here is the total distance that is covered from here to here to here down to here, right? That's the distance that is traveled in meters, right? So how do we calculate the distance traveled by this car in this motion? So the distance traveled will be equal to the area of the ship, right? So that's how we calculate the distance traveled in a motion graph. We look for the area of what? Of the shape. That is equivalent to the distance traveled. So the first shape that I have here, which is from here to here down to here, this is a triangle, right? So this is a triangle. See, this is a triangle, this is a rectangle, and this is a triangle, right? So that will be equal to the area of the first triangle that I have here, which is what? What's the formula for area of a triangle? It is half base times what? Times height plus the area of this rectangle. This is a rectangle, right? From here to here to here to here. This is a rectangle. So the formula for area of a rectangle is what? Length times breadth plus, this is a triangle, right? And it's from here to here to here. So plus area of a triangle, which is half base times what? Times height. So having done that, the next thing I will do is to put in values, right? So this is 1 all over 2 times, what is my base here? My base here is 10 seconds, because from here to here is what? 10 seconds, right? So that will be 10 half times 10 times what? Height. My height, this is not my height, this is the slope, right? My height will be here, right? Which is from here to here, right? This is the height of this triangle, right? Which is from here to here. So how do we look from here to here? So you should know that from here to here represents your velocity, which is here, right? So what's the relationship between acceleration time and what? Velocity. You should know that your velocity is equal to what? Acceleration times what? Time. Velocity is equal to acceleration times time. So that means our velocity will be equal to, our acceleration is what? 1. velocity, the time taken is what? 10 times 10. That will be equal to what? 10 meters per what? Seconds. So this is our velocity, right? So our velocity is 10 meters per second, and this is our height, right? So our height is now what? 10 plus what is the length here? The length here is the height from here to here. That is the length of this rectangle from here to here, which is 10, times our breadth is from here to here, which is what? 20. So times 20 plus half. What is the base from here to here? Is 5, right? Because it decelerates to rest in 5 seconds. So from here to here was in 5 seconds. So that our base is what? Times 5 times what? Our height is what? 10 meters, right? 10 meters per second. So that's our height times 10. So this will be equal to 1 all over 2 times 10 will give us what? 1 all over 2 times 10 will give us 5. 5 times 10 will give us 50. So that will be 50 plus 10 times 20 will give us 200 plus 200 plus 1 all over 2 times 10 will give us 5 times 5 will give us what? Will give us 25. So that will be plus 25. So this will be equal to 50 plus 200 plus 25 will give us 275. So the total distance that is traveled is 275 what? Meters. So it's very important that you should know that in a velocity time graph, to calculate the total distance traveled, you look for the area of what? The velocity time graph, of the shape of this velocity time graph. That's how you calculate the total distance traveled. Then the next thing that we're looking for is the average speed in meters per second. The average speed in meters per second. So we'll put our B here. So what is average speed? Average speed, what's the formula for average speed? Average speed will be equal to the total distance over the total time taken. Total what? Time taken. So the total distance traveled over the total time taken, right? That will give us our average speed. So this will be equal to, what is the total distance that is traveled? It is 275, right? So that will be 275 divided by the total time taken. What is the total time taken? The total time taken will be 10 plus 20 plus 5, right? 10 plus 20 will give us 30 plus 5 will give us what? 35. So divided by what? 35. So 275 divided by 35, 275 divided by 35, that will be equal to 7.8 what? 6. So that will be equal to what? 7.86 meters per what? Second. So this is the average speed of this motion, right? Then the next thing that we will look for, which is the last thing that we're looking for, is the time to cover half the distance. So the time to cover half the distance. So half the distance will be somewhere around this point, right? That will be half the distance. We are asked to look for the time to cover half the distance. So the total distance that we calculated from here to here to here to here, we calculated it to be what? 275 meters, right? We calculated it to be 275 meters. That is the total distance. So first of all, we should know that the so this is for our C, right? We should know that the total distance is equal to what? 275 what? Meters, right? Half half the distance, half the distance will be equal to 275 divided by what? 2. And that will be equal to 137 point what? 5 meters, right? So this is half the distance. Then what is the time that is required to cover half this distance? So first of all, you should know that from here to here, what is the distance that is covered from here to here? From here to here, what distance is covered? So that's the first thing that we would look for, right? So the distance that is covered from here to here is the shape of this triangle, right? The shape of this triangle. The distance that is covered from here to here is the shape of what? This triangle. And we've calculated it to be what? Half base times height, which is half times 10 times 10. That gave us 50, right? So during the acceleration, the body covered a distance of what? 50 meters, right? Or 50 meters. So I would have to write that here, that during acceleration, the distance covered is equal to what? 50 meters, right? Then after acceleration, the remaining distance, since half the distance is 137.5, during acceleration, a distance of 50 meters was covered, right? After acceleration, the remaining distance would be what? Will be remaining distance after acceleration, comma, the remaining the remaining distance the remaining distance will be equal to 137.5 minus what? Minus 50. And that will give us 87.5 meters. So this is the remaining distance, right? So what time is required to cover this distance? So from what we have here, we have that our velocity is what? 10 meters per second, right? The velocity is 10 meters per second. And then we have our distance to be what? 87.5. So we know that velocity is equal to distance all over time, right? So if velocity is equal to distance all over time, our velocity, we calculated it to be what? 10 meters per second equal to the distance we're concerned about here is 87.5 meters divided by what? By the time taken, right? So from here we can cross multiply, right? 10 times t will give us what? 10t. So that will be 10t is equal to what? 87.5, right? So our t will be equal to 87.5 divided by what? By 10, from what we have here, right? So that would be 8.75 seconds, right? So this is the time that is taken to cover the remaining distance of what? 87.5 meters, right? So the time that is taken to cover half the distance will be the time that is taken to accelerate, right? To cover a distance of 50 meters, which is 10 seconds. From here to here is 10 seconds, right? And the time that is taken to cover the remaining half, which we've calculated to be what? And the time taken to cover the remaining half, which we've calculated to be what? 8.75. So the time that is taken to cover half the distance, so time taken to cover half the distance will be equal to 10 seconds. The 10 seconds is the time to cover these 50 meters, right? to the time taken to accelerate, and the distance that is covered here is what, 50 meters. We've calculated it here that the distance that is covered during the acceleration is what, 50 meters. So the time that is taken to cover that distance during the acceleration is what, is 10 seconds, right? 10 seconds. Time taken to accelerate, 10 seconds, right? So that will be 10 plus, which is this 10, plus the time that is taken to cover the remaining distance of what, 87.5, and that is what, 8.75 seconds, right? So if we add that, that would be 18. 10 plus 8.75 will be 18.75 seconds. So this is our answer. This is the time that is taken to cover half the distance, right? So we've looked at what motion is. Motion is the continuous change in position of a body with time. And like I said, motion in physics is studied with motion graphs. We have three types of motion graphs. We have displacement time graph, distance time graph, and velocity time graph, right? And the most important is the velocity time graph. And it shows how the velocity of a moving body changes with time. So this is an example of a velocity time graph. Velocity is plotted against time, right? From here to here, the vertical axis, which is our y-axis, represents the velocity, while the horizontal axis represents our time, right? So from here, from this point A to this point B represents our uniform acceleration, B to C represents uniform velocity, while C to D represents retardation or uniform negative acceleration, also known as what, deceleration, right? And we looked at this example for more understanding. So with this, we come to the end of today's tutorial.